the title. Got this starts. There's the title, compound interest formula, because the title is in it. So, you have your title. The formula that I'm going to give you right now is going to prevent and save time. In other words, remember this table? I got a sense that no one liked this table. I could be wrong. The good news today is that the formula that I'm going to give you makes this table obsolete. We don't have to use this table anymore. We're in the bigger leagues now. I just use this table to kind of communicate step by step how compound interest grows, the whole concept of it. Now you're ready to use the formula that kind of bypasses all this work. The time saver. It's for people who understand what compound interest means, and you guys kind of understand it now. So, coming back over here. What is the formula? Here we go. Here's the formula. It's in red. Go ahead and write it down. I'll go ahead and get it over it. Go ahead and write it down. A equals P times 1 plus R, all in parentheses, to the n power. You with me, Starks, right? Now, what do all these variables mean? What does A mean? Well, it's right here. What does P mean? Copy that down. What does the R mean? Copy that down. And what does the N mean? Copy that down. Nice and clear. You're going to be using this for the next few days, for sure. Without a doubt. Nice and clear. So, A means the amount, or the future value. Because you're going to leave some money in to invest in some account, like an annuity or a compound interest account in general. The future value is how much you want to know. What's going to be the future amount that you're going to get after you leave your money in for so long. So the amount and the future value are kind of the same thing. That's what A stands for in the formula. The principal is called the present value. How much you put in to invest. We kind of know that already, principal. But we look at the rate. The rate is a fraction. It's the interest rate. Remember the percent that we turned to decimal? We've been doing that with interest equals PRT. We know how to do that. But you're going to divide it now by the number of periods per year. So if it's quarterly, that's 4 times a year. If it's semi-annually, how many times per year if it's semi-annually? If the interest grows semi-annually. You guys remember from yesterday? How many times?
6.
So 6 months, so how many times per year then? If it's 6 months, good. How many times per year then?
2.
2 times per year. So you divide by 2 if it's semi-annual. If it's quarterly, it's every 3 months, that's 4 times per year. If it's monthly, how many times per year is monthly?
12.
That denominator would be 12. You see, it just depends on the account. How many times per year does the interest start growing on it? That's what that denominator is. So the R, right here, the formula R is going to be a little fraction. And you're going to see how I use it right now. I'm going to demonstrate right now how to use this formula. And then N, look at the N power. It's the number of years you leave the money in there times the number of periods per year. How many times is interest growing per year? Is it quarterly? That's 4. Monthly? That's 12. Semi-annually? That's 2. How many times is it growing per year? You multiply that by the number of years you're going to leave the money in there for. That's what the N is going to be, the N power. It's going to be 2 things multiplied. The number of years you leave the money times how many times a year it grows interest. Watch me use this now. You have the formula written down. I'm going to demonstrate how to use it. Watch. Example 1. There we go. Just write down number 1 for now. Don't write down number 2 yet. So just number one. Ed Cure invested $2,000, okay? $2,000, by the way, that's at 5.5% interest, compounded quarterly for 2 years. And our mission right now is to do this. We're gonna find the future value. How much money is he gonna have at the end of 2 years if this is all true? This is the way wealthy people make money, ladies and gentlemen. They don't just save money and put it under their pillow. They make their money work for them, and with compound interest accounts. Ed Cure invested $2,000 at 5.5% interest, compounded quarterly for 2 years. Write that down. Let's rock and roll. Here we go. I'll use white. Here we go. Let me write down the formula. A, which is the future value. Remember, A means the future of the same thing. Right here. Okay. It means the future value. The amount. That's what we're after. That's the mission. Find the future value. Ed wants to have his money grow. So the future value is equal to the principal times 1 plus r to the n power. Let's not overthink this, you guys. It's pretty easy. It's not hard at all. We're just going to plug and chug. It's just a matter of plugging the right numbers in the right places and letting the calculator do the work. You're going to plug it. You're going to plug and then press buttons. That's all you're going to do for this lesson. That's not hard. You just got to plug the right numbers, and it's not hard. Watch. Let me go yellow for now. $2,000 is the investment. That's the principal. Watch this. $2,000. 1 plus R. What does R mean again? Let me see. Let me look at our notes. R means, again, the rate per period, which is the interest rate on the numerator and the number of times per year it tax on interest in the denominator. So how many times is the interest tacked on? Anybody? How many times does the interest grow per year? Quarterly, which means what, Mr. Campos?
4.
4 times a year. In other words, every 3 months. Thank you. So before I replace R, let me talk about R real quick. So right now, don't write anything down. Look at wad of cash. Look at that wad of cash right there. Campos just right now correctly said 4 times a year. So here's 1 year. Check it out, Rojo. 1, 2, 3 months is 1 quarter. So there's 3 months. 4, 5, 6 months. There's half a year. 7, 8, 9 months. 10, 11, Christmas time. Here's Santa Claus. That's 1 year. So what this means is, look at Ed. Here's a $2,000 of Ed Cure. He puts it in the account. At 3 months, it earned interest. I'll put plus interest. So far, so good. Put a circle around that. Now, like a snowball, at 6 months, it earns some more interest. I'll put plus I, more interest. Okay, so far so good. 9 months, more interest. So the interest is growing on top of the interest. You guys see that? That's how compound interest works. This is how rich people make more and more money. They're not just working for their money, they're doing that, but their money is working for them. Plus more interest at the end of a year. Now I don't have enough room to draw a snowball, but you get the effect. This doesn't look like a snowball, it looks like a rotten egg or something. I'm not sure what I drew. But notice, how many times did interest grow in the year? 1, 2, 3, 4. That's quarterly. So coming back over here, watch. The rate then is going to be the interest rate as a decimal, which we already know how to do. We've been doing that for the past week, divided by how many times per year. In this case, 4, like Uncle said. Watch. So watch how I'm going to write it. What's the rate, by the way? What percent is he getting? 5.5. Can someone please tell me how to write 5.5% as a decimal, pure decimal? Don't make me cry right now. 5.5% is a pure decimal, somebody?
0.055.
Right, twice to the left. Watch this now. The rate is the numerator, 0.055, divided by 4 times per year. Okay, so far so good. Let me move all this down. My rotten egg, which is supposed to be a snowball, but all to the nth power. Okay, n means the number of years times the number of periods per year. We already know this is 4 times a year, it's quarterly. But the number of years, how many years has Ed cured does he decide to leave his money in here? Let's see. 2 years. So check this out. The n is going to be 2 times 4 power. Look at that. You meant to stay with me. So check it out. Let me simplify this a little bit. 2,000, parenthesis, 1 plus 0.055 divided by 4, all to the 2 times 4 power, which is just 8th power. We're not going to do all this math in our head and use a bunch of paper. We're going to let the calculator do all that work. Watch. It's beautiful. So the scientific calculator is on C24. Watch. Right here, today's assignment. It's Desmos calculator. You're going to bust that out. Thank you, Dominguez. So watch this. Watch this. Let me get my calculator out. Come back over here. Look at what I'm going to do. I'm just going to type that stuff in. The beauty of this calculator is you can type in all kinds of expressions very easily. Okay? Hold up here. Put that right there. So, 2,000, close parenthesis. I can type all this in. This was 1, by the way. So 1 plus, let me backspace here, 1 plus 0.055, look at divided by, look at there's a fraction there. It allows me to do it. So easy. Right, Jimenez? Divide by 4. I'm going to close the parenthesis. I'm just doing exactly what I wrote. It's a beautiful calculator. It does all the work. And now to the 8th power. What am I going to press for the 8th power? Well, remember in warm-up? I'm going to press the A to the B power button, and it allows me to type in any exponent. So it's the 8th power. There it is. So Ed Cure, after 2 years of leaving his $2,000 in the bank, is going to have $2,230.80. I'm running to the nearest penny now. Running to the nearest penny. It's the second 8. I look to the right of it. It's not 5 or bigger, so the 8 still stays 8 pennies. So it's 88 pennies. So 2230.88. So $2,230.88 is a future value. So his money's going to make $230 in 2 years just by letting it sit there. Savings accounts won't do that for you at the bank. Only compound interest accounts grow that fast. He's just letting his money sit there. This is $2,000. That's not that much money. But he made $200 in 2 years. $230 in 2 years just by letting it sit there. Let's do one more example. I'm going to go quicker now. Any questions so far? look at number 2 now. I'm gonna write this one down. Let's do Louisa now. Louisa Foster. Last example. So Louisa Foster invested $4,500 at 3% interest, compounded semi-annually for 2 years. Compounded semi-annually for 2 years. Okay? I'm blocking number 1 now. So we're just focusing on number 1 now, or number 2 rather. Louisa Foster invested $4,500 at 3% interest, compounded semi-annually for 2 years. Last example. Write that down. Give you another minute. All right, here we go. Okay. The future amount is the principal, it's 4,500 in this case, times 1 plus the rate now. Remember, it's a fraction. The numerator is the percent, 3% over how many times it's going to tack on interest in a year. Starks, what does semi-annually mean? How many times a year?
6.
Good, that's every 6 months. So how many times per year?
2.
Twice. So I know the denominator then is going to be 2. How many times a year is the denominator, and the percent's the numerator, but as a pure decimal? Someone besides Campos, please turn that into pure decimal for me.
0.03.
You're awesome. All to the, watch this now, nth power is the number of years times the amount of times per year. The number of years is 2 years, so it's 2 times twice a year, huh? So it's 2 times 2. 2 years, twice a year. The 2 times 2 power. Again, that's what n means. You wrote that down about 10 minutes ago, right here. Right here. N means the number of periods, which is equal to the number of years times the number of periods per year. Coming back over here we go. Almost done. Let me get my calculator. Remember, I left the Desmos calculator link on C24. Let's rock and roll. Move this right there. Here we go. All right, 4,500, let me clear this. 4,500, parenthesis, 1 plus 0.03 divided by 2, close that parenthesis, to the fourth, that's the 4th power, because 2 times 2 is 4, so it's going to be the 4th power. Rocking it. So Louisa is going to have $4,776.14. That 3 is in the pennies place. To the right of it's 5 or bigger, so it goes up to 4 pennies. 4,776.13. $0.13. Well, 14 cents rather. There's Louisa's future value of her account. So her money sitting there is going to make about $226 in 2 years, just sitting there at 3% interest. Awesome, awesome. You're going to try this on your own. One, remember this is for your R stamp. Just one problem on your own. If you're having trouble, I'm going to walk you through it individually, and then finish your flip grid and mark this as done. One flip grid question based on your notes. And the problem you're gonna do on your own is this right here. Boom, it's Elliott Frazier. Bigger money now, it's 10 grand. Into a savings account paying 6% annual interest compounded. Compounded monthly. Not quarterly, not semi-annually, monthly. It's tacking on interest monthly. Think about how many times a year that is. What amount will he have in his account after 5 years? Don't worry about this part. Just how much money is going to have in an account after 5 years? Try that on your own. I'll be walking around to help, and you're done for your R stamp. The P stamp is just a simple add puzzle. No, flip grid, and you're rocking and rolling. Hit it. By the way, if you're absent and watching this video, you have to do this for guided practice if you want the R stamp.